We are back once again. It is daily LeetCode. Another day, another dollop of suffering. No, not really. I didn't get to do an earlier session today, so we're doing a later session after work. But it is, yes, we are alive. We do be alive, and we do be monkeys, low key. But yeah, I said today we were gonna work on min cost to climb stairs, but I didn't get a chance to read the ADM, so I think it's safe to pause on that problem for now and accept our fate. And it is, as always, weekly contest time. I want to start doing it on the day it actually starts, like on Saturday, maybe live or something, but it has not been the case yet. Also, my YouTube environment is still broken, so I still can't view the comments. I'm hoping to fix it today. I just have to turn off a setting, but yeah, I just turn off a setting, but I keep forgetting to, and then it locks, so I can't change it. So that should be done soon, but it's just one of those days. So I think we're just going to jump into it. I'm not surmising. I'm surmised this will not be the best session since my brain is kind of fried from work already. But nonetheless, we shall try some quick analysis. These times are a little bit longer than usual. Usually we have a range from like 6 to 9 minutes. Our range now is 8 to 10 minutes for the top 5. So it seems like this one was actually kind of difficult. We already see here number of arrays with GCD equal to K. I don't even know how greatest common divisor works. So likely that problem will be impossible to solve. So we'll try as usual and see how far we get. So you are given two arrays of strings. So we're given two arrays of strings that represent two inclusive events that happened. Two inclusive events that happened on the same day. We're given two arrays of strings that represent two inclusive events that happened on the same day. Event 1 and event 2, where start time sub 1, end time sub 1, and start time sub 2, end time sub 2. Event times are valid 24 hours format in the form of hours and hours:minutes. A conflict happens when two events have some non-empty intersection. Some moment is common to both events. Return true if there is a conflict between both events. Otherwise, return false. So we have two arrays with the start time and an end time, but how many elements can be in this array? So it looks like their lengths are always 2. It's always 5 characters, so 2 numbers for hours and minutes plus the colon. Interesting. Interesting. So a conflict happens when two events have some non-empty intersection. Some moment is common to both events. So in event 1, we have 1:15 to 2. Event 2, we have 2 to 3. Looks like they have a conflict because two events intersect at time 2. Event 1 starts at 1, ends at 2. Event 2 starts at 1:20 and ends at 3. Two events intersect starting from 1:20 to 2, right? And here we have 10 and 11, and then we have no conflict because it starts at 14. Looks like it's 20. Yeah, they said it earlier, 24-hour time. I kind of want to just say, we could just say, hey, check if event 2 sub 1 is less than or equal to event 1 sub 1, which would be this number here. That works for this one because 2 is equal to 2. 120 is less than 2 here. And we get false here because 14 is not less than 11. So does that scale? What if we swap it? What if we swap the times? If we had event 1 was 2 to 3 and event 2 was 115 to 2, right. So that would, if we swap them, that actually breaks what I'm thinking of. So maybe we have to figure out which is earlier, which is latest. Then we could say if latest sub 0 is less than or equal to earlier sub 1, we could just return true. There is a conflict. Maybe that is too simple. Maybe the hardest part would be converting this hour and minute timestamp into a usable amount or usable value. Then we can just split by colon and then take a look at the numbers converted to integers. So we could simply check. We could create a function to compare 2 times. It would just make sure that if 2 is less than or equal to 2 and the minutes are less than or equal to the other's minutes, then it would be less than or equal to. Or we could just treat the numbers, we just delete the colon and treat it as an integer instead. I think we'd get the same answers. So let's try that. It seems like that would work. So we just have to figure out which one is earlier and which is latest. So we could do is say the latest would be if event sub 1 dot split by colon dot parse int. We can just do this actually. We'll just say const event 1 int equals this value. And then we'll say event 2 int equals the same thing except event 2 instead, a different variable. And then this way we can just say event 1 int is less than event 2 int. Then latest would actually be event 1 int. Otherwise it would be event 2 int. Actually these are arrays. So what we actually want to do is take the start time. So we'll do event1 sub 0. Right, so now that we have it set to event 1, how do we can just actually do object comparison doesn't really make any sense. If event 1 int is less than event 2 int, we'll set latest equal to event 2 to event 1. We want the shortest, we'll say if event 1 int is less than event 2 int, then shortest is equal to event 1, otherwise it's equal to event 2. So basically if we had start times 1 and 2 p.m. or 1 and 2 a.m. event 1 int would be 100, event 2 int would be 200. Now is 1 less than 100 less than 200? Yes, we put event 2 as latest. I would say, okay, is event 1 less than event 2? Yes, we get event 1. So I think this actually does work. And actually, let's try one more where we swap it. If we say event 1 is 2, right, and event 1 is 100, so we'll say event 1 int, which is 200. Is 200 less than 100? No, which means latest is event 1. Now, is event 1, which is 200 less than 1? No, which means that shortest is event 1. Yeah, this word falls apart. Let me check something. Not shortest, but we'd like this to pretty much be earliest. And then we'll just return true here. Forgot to join it back together, so we split by colon and we'll join it back together. So earliest would be this one and latest would be this one. If we use a custom test case where we just swap the time around, wait, it feels like it works here. event 1 it would be 200. Event 1 int would be 200. Event 2 would be 100. What 200 is not less than 100. So latest would be event 200 is not less than 100, which means the latest would be event 1. If 200 is not less than 100, that means earliest would be it just makes no sense. $200 is not less than 100, which means latest is now event 1. Event 1 is 200. 200 is not less than 100, which means that earliest is now event 2. I guess it does work. That's strange. But I guess that is okay. And then what did I say earlier? We just need to check that we can make a function called toInt, and it'll just take an array of strings and return a number, and it can just do what we're doing in here. So we'll just pass it a string. We should still be good. We'll just print this one more time. Okay, so we look fine here. I think all we should have to do now is check that if latest sub 0, so we can do toInt is less than or equal to toInt of earliest, but it's end time, then I think that means you have a conflict. Yeah, it's interesting. I feel like we knew the answer from the start, but yeah, there's an issue I had with this logic right here that I didn't work out in a previous problem. So we kind of had to figure it out. Now I realize you can just compare them based off one aspect and then just flip the case. I mean, keep the cases the same except flip the output, and you can slot them in a separate bucket. So that is useful for another problem in the future, I'm sure. Oh, greatest common divisor. Given an integer array nums, so you have an array of numbers and an integer k, return the number of subarrays of nums where the greatest common divisor of the subarray's elements is k. So we have an array, we have an array of numbers and k. I want to return the number of subarrays of nums where the greatest common divisor, the elements. Subarrays would mean they're contiguous. Is 3 the greatest common divisor of 6? Is 3 the greatest common divisor of 6? Greatest common divisor. Wouldn't 6 be the great? Oh, I guess they're not. They don't have it in common. I guess the greatest common divisor they have would be 3. Okay, the greatest common divisor of an array is the largest integer that evenly divides all the array elements. So we have an array here, 931,263. We want to return the number of subarrays where the greatest common divisor is k. So I think we'd have 4, I think because 3 counts as a subarray, 3 and 6 count, 9 counts as a subarray, and 9 and 3 count. It seems like this could be done with sliding window pattern, and if we had a function to figure out the greatest common divisor of two numbers. Do 9, 8, 7. Maybe we could brute force it. Greatest common divisor has to be k, so maybe we could brute force it. If we start at 9, could pretty much iterate from the number itself and then go up to k. If we could go down to k. think we could sliding window this and then pretty much just do the GCD of the current element and the next element. So we'll do the GCD, we'll do the greatest common divisor of the current element. Oh, we'll check if the first element is divisible by 3. If it's divisible by 3, that's fine. And then we'll go to the next number and say, hey, what's the greatest common divisor of these two numbers? If it's k, we can add another point to result or answer. And then we'll say, what's the greatest common divisor of these? It's clearly not 3. So we'd stop there. We try to restart. I guess we could skip that number and go to 2. We'll check if it's divisible by 3. It's not. Check if 6 is divisible by 3. It is. So we can add 1 to our answer. Then check if the GCD of both of these numbers is 3. So I would say the sliding window relation on first element with mod 3 equals 0, then check then check current element with next using GCD. Actually, then we can just say, then check GCD of 2 equals k. If it equals k, then we can add 1 to result. We can paste this down here just so we don't have to keep sliding up. So from there, I think we just need a GCD function. I think we can brute force a GCD, but I don't know of a mathy way to do better. So maybe we'll try that version. Function called GCD of num1, which will take a number, and num2, which will also be a number, and we'll return the GCD. The way I'm thinking of doing it is if given a number like 9 and 7, and we'll go from starting at 9 going all the way down to and including 1. We'll divide it by the number, see if it divides perfectly into it. If it divides perfectly into it, then we'll add it to a set, and then we'll do the same for 7, and then we'll take the union of the set and then sort it and take the top element. That would be the greatest. If we take the union, that'll be the great common, and then greatest will be the sorting of the keys, so we can sort. I mean, this would be a crazy time complexity. This would be crazy. We'd be sorting. Also, if the number given to us is num sub I can go up to 10 to the 9. So I don't think this is going to work. I think the solution could work. We just need a better way of figuring out the greatest common divisor. The GCD. Greatest common divisor of two numbers. What if we just start from the lower number and we could bring our crazy GCD runtime down to linear time? So we'll say smallest is equal to, if num1 is less than num2, then smallest must be num1, otherwise it must be num2. We'll say largest, you can just say if num1, if smallest equals num1, then largest must be num2, otherwise it must be num1. And then what if we just said starting from 1 and going up to and including smallest, we could do linear time instead of having to sort, and then our divisor will actually be smallest minus I. We'll say if num1 mod divisor, if num1 mod divisor equals 0 and num2 mod divisor equals 0, then we'll just return divisor. Otherwise, they share no common G, and we'll just return -1. So in this case, let's just return 1 or 0 as an answer, and let's try the GCD function. Try 3 and 9. And what's some other numbers? Try 4 and 7. So we should get 3, -1, -1. Oh, well, I guess we can't include 1. But yeah, maybe we can include 1. Greatest common divisor. I guess they'll always have, every number has the greatest common divisor of 1 except for 0. So what if we did 4 and 0? Maybe this is acceptable. So maybe we'll run with that to see if it works. So let's try the sliding window. Pretty much we'll do iterate over every number in nums. And then we'll have something like ands, which is equal to 0, which is what we'll return. And then we'll say we pretty much want the number of subarrays that share a greatest common divisor. So the first thing we can do I think we need to keep track of our length of our array, length of our subarray, or length of our window. And this is because if our window length is less than, if our window length is 0, then we're looking for like a element to start, and then we can start doing the GCD. So what we can say is if window length is equal to 0, we pretty much want to just check if I is divisible by 3. If it is, we'll increase the window length. And our answer. And then in our else clause, we can just check that the GCD is equal to K. And if it is, then we're going to increment our answer and our window length. Otherwise, we want to reset. Okay, yeah. Otherwise, we want to reset our window length. So I think what we want to say is if window length equals 0, then we can also do like this. If window length is equal to 0 and num sub I mod 3 equals 0, then we want to say window length plus equal 1. Ands plus equal 1. Else if window length does not equal 0 and the GCD of nums sub I minus 1 and num sub I equals K, and we'll say window length plus equal 1 and plus equal 1. I guess we could combine these two keys. Actually, no, we couldn't. Yeah, we couldn't. I guess we could. It's just two ors, and the code in the center is the same. But otherwise, we want to say window length is the value of 0. So if you can just check if this works, start with 9. Right, window length equals 0 and num sub I, which is 0, mod 3 does equal 0, window length plus 1, answer plus 1. Then we try to extend the window. So else if window length does not equal 0 and the GCD of 0 and 1 equals K, it should, and then we'll do, okay, window length plus equal to answer plus 2. Then we go to 1, we do the GCD of 3 and 1 is 1, which is not equal to K, and this should be K as well. So you do window length equals 0. We go to 2. Window length is still equal to 0, and mod 3 does not give us 0 here. We finally get 6, which does give us 0, and then we go to the next indice, which should give us a GCD of them both being equal to 3. Works for the first case. I'm pretty sure the answer for the second one is supposed to be -1. Oh no, the answer of the first one is 0. Oh yeah, because there's no subarrays. Okay. It's affected 0 here. Why is that? Is it because an element of length 1 that doesn't make sense though, because they underlined 3 and 3 in both of these scenarios. So it just makes me think that you can include the elements as they are, or an individual element. I guess if the array's length is equal to 1, just return 0. Because you can't have a subarray of an, I guess you can't have a subarray of an element with 1. Wait, this doesn't make any sense. The greatest common divisor of 5. They expected 0. The GCD of 5, the greatest common divisor of 5, is 5. I think maybe that's what they're trying to say. You should be able to do the GCD of a singular number. So I think we can just duplicate this function. Maybe we could augment it to use one parameter. We don't have the brain power for that right now. Just going to change the function to use one number. You know what? Actually, it might just be better if we just augment the function instead. Oh, no, actually. I think we should be able to overload this like this. Oh, no, you get duplicate function implementation. We'll just make this called GCDS for GCD single. I think I need to remove all of these console logs because this is unreadable. Answer is 2, which is wrong. Should be 4. So what if we just keep the first one the same, except if nums.length equals 1, we return GCDS of num sub 0 equaling k. Or yeah, if it equals k, we'll return 1, otherwise we'll return 0. So we get 0, 1, 0. This makes sense. No common divisor. There is one here. Then 0. So let's try resubmission. I see. Yeah, I think mine's is looking more at unique subarrays because we have 3, 12, 9, or it does linear time 3, 12, 9, 6. They want all subarrays, so 3, 12, 9, 6 is 1, 12, 9, 6 is 1, 9, 6 is 1, and 6 is 1. So you get 1, 2, 3, 4. Actually, I'm not exactly certain how they're getting 7. I don't understand how we're getting 7. I feel like this is one of those problems where the examples given aren't very good. K is equal to 3, which means if we're looking for all subarrays, this would be like 16 subarrays. We'd have 3, 12, 9, 6. Then we'd have 3, 12, 9, 3, 12, 3. We'd have 12, 12, 9, 12, 9, 6, 3. So it seems like the answer should be 16, but it's 7. Return the number of subarrays of nums where the greatest common divisor of the subarray's elements. Greatest common divisor of the subarray's elements is k. I'm not quite following. I don't understand. I don't understand. They're ending up with only 6. They're only ending up with 7. How is that possible? Oh, wait. We get 3, 12, 9. That's one array. 3 is one array. 3, 12 is another way. 3, 12, 9 is one more, which would be 3. Once we add 6, the greatest common divisor of the entire subarray is not 3. It's... Well, yeah, the greatest common divisor... So largest number that evenly divides all the numbers in the array would be 3. I don't understand. This one I don't get. I'm not exactly understanding why the answer is 7. It doesn't even say unique. Let's just try and make it. Let's just generate all of them, so we get 16, and then make it unique and see if that is what it wants. We'll change this to be. We'll keep this as I and just make the outer one equal to m. And then we'll just say I is equal to m. I have a set. Actually, let's see From here we should get 4, 3, 2, 1. 4 and 3 is 7, 2 is 9. So we should get 10 like this. Now, if we get 10 like this, we can use a set of strings and we'll just try and make each subarray unique, which means we no longer need window length, so we'll just use an array. So everywhere we had window len, we'll change it with window.length. Everywhere we had window plus equal 1, we'll just do window dot push sub I. Now every time from here, actually this still makes no sense because we do have all unique arrays. So if we change this from a set to an array, anytime we do window dot push, we'll just do ours dot push window dot join. Oops, I was supposed to print ours. So it looks like we just keep printing 3. Oh, I think I should have. What is going on? We have just massive strings in here. Maybe we need to reset the window after each for loop. Three, 12, 9. We have 3, 12, 3, 12, 9, 6. They have 12, 12, 9, 6, 9, 9, 6, 6. Yeah, so they're all already unique. So the point of you making them unique didn't quite make any sense. Yeah, it's unclear. I guess part of the problem is figuring out what problems want, but I just can't quite figure out what this problem wants. So I think that's where we'll stop.